Hello and welcome to my YouTube channel. In today's video I'm going to show you a simple way to find any term of the binomial expression a plus b to the power of n, where a and b can be variables or constant and n is any positive integer like 0, 1, 2, 3, etc, etc, without actually expanding a plus b to the power of n. These are 4 examples we are going to solve in this video. In each of the questions, I highlight the keywords in red. Question 1, find the fourth term of the binomial expansion of this. Question 2, which member or term of the binomial expansion of the algebraic expression this contain x to the power of 6. The third question is find the middle term of the binomial expansion of this. And then last question is find the coefficient of the x to the power of 3 y to the power of 4 term in the expansion of 2x plus y to the power of 7. With these 4 examples solved, you can be able to find any term of a binomial expression raised to any given power without actually doing the expansion. So without further delay, let's dive in. You are welcome back. Example 1. Find the fourth term of the binomial expansion of x plus 2 to the power of 7. So for any binomial expression, a plus b to the power of n, the r plus 1 term is given by tr plus 1 subscript is equals to n combination r a to the power of n minus r b to the power of r. For r, take values from 0 to n minus 1. So when r is 0, then we have the first term. When r is 1, we have the second term. When r is 2, the third term. And when r is n minus 1, then we have the last term. So this is from where we are able to get the term. So we are given this question, x plus 2 to the power of 7. So from this, we can see that our a is x, our b is 2, then our n is 7. Now, we want to find the r. From the question, we say the fourth term. Since the fourth term, we're talking about the fourth term, our r is going to be 4 minus 1. It's going to be 1 less than the n, because it takes from value of 0 to n minus 1. So 1 less than n. And this will give us 3. So therefore, consider the fourth term is given by t3 plus 1 subscript, and put them in the formula. Our n is 7. We have 7 combination 4, combination 3, 3 combination, because our r is 3, 7 combination 3. Then I have my a, our a is x, n minus r, that is 7 minus 3, this 3 here. And our b is 2, then 2 to the power of our r, which is 3. And this gives us 7 combination 3, which is 7 factorial over 7 minus 3, it's 3 factorial. Then 7 minus 3, we have 4 factorial. Then we have x to the power of 7 minus 3, which gives us 4. Then 2 to the power of 3, which gives us 8. From there, we are going to get the value of, let's multiply, we're going to get 7 times 6 times 5 times 4 factorial over 3 factorial, we leave it, which is 6, 4 factorial, then times 8 times x to the power of 4, then 4 factorial cancel this cancel this, then our result we are going to get 280 x to the power of 4. So that is the answer to this question. So we say find the fourth term of the binomial expansion of x plus 2. So we compare this with this. We get our a is x, our b is 2, and our n is 7. Then from the fourth term, so our r is going to be 1 less than the term, which is 4 minus 1 would give us 3. Then the fourth term is going to be t subscript 3 plus 1. Then our r is 3. Then apply a formula, we have 7 combination. R is 3. Then x to the power of 7 minus 3. 2 to the power of 3. Then 7 combination 3 is 7 factorial, 3 factorial. Then times 7 minus 3, which is 4 factorial, s to the power of 4. Because 7 minus 3 is 4. Then we have 2 to the power of 3, which is 8. Then break this one down or use calculator straight away. Then multiply this value with 8. You are going to get 280. Back to the next question. Example 2. Which term of the binomial expansion of the algebraic expression 2x minus 1 over x to the power of 14 contains x to the power of 6? So to do this, just like we did the other time, say the r plus 1 term, the r plus 1 term is this, is n combination r, a to the power of n minus r, b to the power of r. So we need to evaluate this r plus 1 term, and our n here is 14 combination r, which is unknown. Then our a is 2x. From here, this is our a, which is 2x to the power of 14 minus r. Then our b is this, which is minus 1 over x to the power of r. R is unknown. Right from here, this is 14 combination r. Can split these two, apply law of indices. We have 2 to the power of 14 minus r. Here we have minus 1 to the power of r, minus 1 to the power of r. So the whole of this will be a number, because this is r. This will be 14 combination r will be a number. 12 to the power of 14 minus r also be a number. Then minus 1 to the power of r will also be a number. So we are left with x to the power of 14 minus r. Here is 1 over x. This will be x to the power of minus r. And this we are going to have 14 combination r, 2 to the power of 14 minus r, minus 1 to the power of r. Then combine these two using law of indices. That will be 14 minus r minus r. This will give me 14 minus 2r. So the next thing we need to get is to get r command. We set this part here, which is x to the power of 14 minus r, to be equals to x to the power of 6. Because this will allow us to get the term that have the power to a 6. So we need to equate whatever we have here is going to be a number. So the number is not important for now. What we have there is the power of x here has to be to the power of 6. That means this x to the power of 14 minus r has to be equals to x to the power of 6. So if you equate the powers, we are going to have 14 minus r is equals to 6. So this implies our r minus 2r, I'm sorry, is going to be minus 2r minus 2r. 2r equals to this. So our r is going to be 14 minus 6 divided by 2, which is 8 divided by 2, which is 4. So since our r is 4, so we can say So we can say the term in x to the power of 6 is what? Is the fifth term. Is the fifth term. So we add 1 to this to get the term. So the fifth term. So that is the answer. Welcome back to question number 3. Find the middle term of the binomial expansion of root of x plus 2 to the power of 6. So let's write the question down. We have a root of x plus 2 to the power of 6. So in this case, it implies our n is 6. So for a binomial expansion, the number of terms is n plus 1. So since the power is 6, then we are going to have 7 terms, and so there will be a middle term. If the power is even, then there will be a middle term of a single term will be at the middle. Or if the value ai is odd numbers, there is no way we can able to get the middle term. So since it's even number, then we're going to have 7 terms. The power is 6. So in that case, we can see that our middle term, the middle term is going to be 6 divided by 2 plus 1. So we divide by 2, add 1, and that will give you 3 plus 1, which is 4. So since it's 4, then that implies our r is now going to be 1 less. That is 4 minus 1, which is 3. Since we are told that the r plus 1 term is going to be n combination r a to the power of n minus r and b to the power of r, or r range from value of 0, 1 up to n minus 1. So we have this value. So therefore we have to get tr plus 1 is now going to be then 3 plus 1, which is t4. And t4, substitute in the formula, our n is 6. So we're going to have 6 combination. R is 4. Our a here is root x. That is root of x to the power of 6 minus 4. 6 minus 3, because our r is, here is supposed to have 3. 3 plus 1 is 3, then we have 3, 6 combination 3, root of x to the power of 6 minus 3, times that of our b. Our b is 2 to the power of 3. Then we are going to left with 6 factorial over 3 factorial. 3 factorial is 6 combination 3, and this is root, that is root of x to the power of 6 minus 3, which is 3, 2 to the power of 3, which is 8. 6, this we are going to have 6 times 5 times 4 times 3 factorial over 3 factorial times 3 factorial. Root x to the power of 3 will give us x to the power of 3 over 2. Power of 3 over 2 times 8. So multiply 3 factorial, cancel 3 factorial, then 3 factorial, which is 6, cancel 6, then 5 times 4 times 8. We end up having 160. Then we have x to the power of 3 over 2. So therefore we consider the middle term. The middle term is going to be equals to 160 x to the power of 3 over 2. Hello, welcome back to example 4. In this question, we are going to find the coefficient of the term x to the power of 3, y to the power of 4, term of the binomial expansion of 2x plus y to the power of 7. So let's write the question. Rewrite the expression, which is 2x plus y to the power of 7. which implies our A is 2x, our B is y, our n is 7. Then from this question, we need to get the term. The r plus 1 term is n combination r, a to the power of n minus r, b to the power of r. Substitute the values. N is 7 combination r. R is unknown. A is 2x to the power of 7 minus r. Our b is y to the power of r. Then we're going to have 7 combination r, 2x to the power of 7 minus r. So we can separate the two. We have 2 to the power of 7 minus r. Then the whole of this will be a number. They are going to have x to the power of 7 minus r, then y to the power of r. So we need to get r so that we're able to know the coefficient. So this part will be the coefficient and this will be the term. So in order to get r, so that the x times y will look like x cubed to the power of x to the power of 3 and y to the power of 4. To do that, say to get r, we set x to the power of 7 minus r, y to the power of r to be equals to x to the power of 3, y to the power of 4. So we can equate any of the power. Either we say r is 4 or 7 minus r is 3. We still get 4. So it means r is going to be 4. Since r is 4, so therefore we say the coefficient is now going to be this one in bracket, which is 7 combination. Our r now is 4. Then 2 into 7 minus 4. This will give you 7 factorial over 4 factorial, 7 minus 4, which is 3 factorial. Then we have 7 minus 4, which is 2, minus 4, which is 3. And this 7 factorial, which is 7 times 6 times 5 times 4, divided by 4 factorial, 3 factorial will cancel 3, 4 factorial will cancel 4, times 8. The answer will be 280. So therefore, we can say that the coefficient is going to be 280 for this time. So from this, we get our a, which is 2x, b is y, and n is 7. Then the r plus 1 term is to be n combination r, a to the power of n minus r, and b to the power of r. Then we replace n to be 7 and r to be r because it's unknown. We know our a is 2x from here, and our power is n minus r. N is r is r. So whatever we do, we separate the 2 and x together and join with the other one, form a number we have with x to the power of 7 minus 3 y to the power of r. So in order to make this to look like this, then we need to equate so that we get our r. So either say 7 minus r equals to 3, or we can say r equals to 4. Anyway, r will be 4. So we replace the value of r back into this one in the bracket, which is a number, and that number gives us the coefficient. Doing this simplification, and the end result is going to be 180.